gotten the first 3 conic sections under our belt. So that's what we're going to do right now. We're going to review and practice these. So let's see what number 1 is. What is number 1? What is this? See, in order to answer the questions, you have to be able to tell what it is. So what shape is this? A what? It's an ellipse. How do we know it's an ellipse? You have to be able to look at it and tell kids. How can you tell it's an ellipse? You've got 2 squares, right? That rules out the parabola. You have 2 squares. They're added together, and their coefficients are different. Okay? If you have 2 squares added together, and the coefficients are different, you have an ellipse. So here we go. It says I need to find the center, the vertices, the foci, and the major and minor axis length. All right, so here we go. Got to get this thing in standard form. Remember how we did this? We're going to complete the square twice. We have to complete the square on the x's. So I'm going to group my x's together and factor out a 4. Now I know I'm going to complete the square. So that's what I'm leaving this blank for. I'm preparing to do that. Now I'm going to group my y's together, and actually there's really nothing to factor out. I'll just put a 1 there, which I don't need to put there. I just put it there because usually there's a number, but there isn't this time. So I'm going to move my 21 to the other side, put a couple blanks over there because I got a couple blanks over here. All right, everybody good? So now we're going to complete the square. Here we go. Half of 6 squared, but that's really a 36. So 36 is what gets added over here. That's a place where we can make a mistake if we're not paying attention. All right, what completes the square here? Half of 2 is, squared is 1. 1. So I have 4x plus 3 squared, that's my square, plus 1y minus 1 squared equals 16. Everybody still with us here? We're going to divide by 16 now. So when I divide everything by 16, we have x plus 3 squared over 4 plus y minus 1 squared over 16 equals 1. Now my ellipse is in the form I need it to be in order to find all the stuff I'm supposed to find, right? So in my ellipse list, it says find the center. Okay, what's the center? -3, 1. Now remember, nobody's grading your picture. You're using the picture optionally to place things. Alright, so there's my center. Now I need my vertices. Alright, so my vertices are going to be found by going sideways, 2, and up and down 4. This is the x radius, this is the y radius number. So I'm going to go sideways 2. So I'll be at -1, 1 and -5, 1. Remember, you can bring some graph paper if you think it might help you. And then I'm going to go up and down 4. 1, 2, 3. So I'm at -3, -3. 1, 2, 3, 4. -3, 5. I'll connect these dots. There's my ellipse. All right, how long's my major axis? That's one of the pieces of information we want there. The major axis is 8 because we went up and down 4. How long's my minor axis? 4 because I went sideways 2. My foci are always on the major axis. So this time, this is the major axis. So my foci are somewhere on there. Again, nobody's grading the picture. Just put them on there somewhere. We need to figure out where they are. I don't know, but I do know the x part's -3, right? Would you agree with that? Now, I need to know how far up and down to go. So center to focus, that would be this distance right here. The center up to the focus. In this ellipse would be what? Square root of 12, or 2√3. So that means I'm going to start right here at the center, and I'm going to go up 2√3. So what will be this y coordinate here? If I go up 2√3, 1 plus 2√3, and then this one will be 1 minus 2√3. Subtract the denominators and take the square root. That should be in your notes already. If it's not, you want to get it there. Distance from center to focus in an ellipse. We're going to subtract the denominators and take the square root. That keeps the foci inside the ellipse. All right, anybody else have a question about that problem? That's an ellipse. Alrighty? All right, next problem. What's this guy? Number 2. What is he?
Circle.
He's a circle. Now, how do we know he's a circle? 2 squared terms added together, but the coefficients are the same. That means that your x radius and your y radius are going to be the same number. So obviously that means you're going to have a circle. Alright, so we're going to get this guy into standard form, and we're going to do it exactly like we did the ellipse, right? Alright, so here we go. X squared minus 4x, y squared minus 6y. Move that 2 over. Everybody okay with that setup? Just like the ellipse, except you don't have the factoring piece. All right, let's complete the square. What goes here? 4. Both sides. What goes here? 9. Both sides. So we've got x minus 2 squared. That's this guy. Plus y minus 3 squared. That's this guy. Equal to 15. Now this is a circle, and the only thing you have to write down or figure out for a circle is the center and the radius. If you want to draw a picture, that's up to you, but I don't think you probably need it this time. It's up to you though. What's the center? 2, 3. And the radius is? Square root of 15. Remember, x squared plus y squared equals r squared. Right? So r squared is 15, r squared is 15. Everybody all right with that guy? Circle? All right, and then we got number 3, which is what? What's this? This is a parabola. And how do we know that? By looking at it. We've got 1 squared term. Now, just like with the circle and the ellipse, we need to complete the square. But the good news is we only need to complete the square once because there's only one square. So let's get everything squared over here. And just like before, move everything else to the other side. So I'm going to complete the square on my X's. Here they are. Move everything else to the other side. All right, what completes the square here? 25, both sides. So x plus 5 squared equals 8y minus 24. Right? And then let's do one more thing. What's the last thing we want to do with this equation? Factor out that 8. And there we are. Now, for a parabola, we need a whole bunch of stuff. So here we go. Where's my vertex?
-5, 3.
-5, 3. Which way, oh my gosh, get this right. Some of you missed this on your quiz and this is deadly. Which way does it open? Now pay attention, there's two things you should be zeroing in on. One is, which letter is squared? X! This is your BFF, y equals x squared. The other is whether that number right there is positive or negative. So it's x squared, positive. This one opens up. Which means that its axis of symmetry, I don't even know if I asked you for that or not. I didn't, but oh well, let's write it down, because you never know, I might sometime. What's the axis of symmetry of that parabola? X equals -5. Here's my focus. This right here, the distance from the vertex to the focus is P, right? And in every equation in standard form that you have, this number is 4P. So 4P is 8, which means P is 2, which means I'm going to go up 2, which makes this point what if I go up 2? -5, comma 5. Now if we went up 2 to put our focus, we're going to go down 2 to put our directrix. So our directrix, which is a line, we're tempted to make it a point, but remember it's a line. If we come down to, where are we? Y equals 1. Now, this segment right here is called the latus rectum. How long is it? That's also called the focal width. The width of the parabola through the focus is 8. The length of the latus rectum is 8. That means all the way across is 8. So we know where the middle is, and here's the middle point, -5, 5. So to find these two, I'll just start there in the middle and go back and forth 4. So if I do that, where will this point be? I'm going to start right here at my focus. It's going to be at
-1, 5.
So -1, 5 would be this one over here, right? And -9, 5 would be this one. Going back and forth, 4.
How do you know if it's pointing up and down or side to side?
The parabola? Okay, remember, x squared is up and down. Positive and negative tell you positive is up and right, negative is left and down. Alrighty? Well, Francis, what are you doing back there? Guess what's going to happen tomorrow? You're going to have a quiz. Now, some of you aren't going to be here tomorrow for class, but feel free to come in early in the morning and take the quiz before you leave. All right? If you're going to be on your field trip for English or wherever it is you're going. All right.
Quiz over this stuff.
Quiz over what we just did. All right, so now we're going to pick up where we left off with the hyperbola. Now, we only did one example, so we're going to just start in with another basic example of a hyperbola. All right, so this goes back to your notes. If you were taking notes the other day, the last thing we did was a hyperbola, and I don't know if we even finished it. So I'm just going to start a new one, and we'll go from there. So let's suppose we have this hyperbola. Now, first of all, that equation looks an awful lot like the equation of the ellipse that we did a few minutes ago, right? What's the difference? It's a minus. If you have squared terms, 2 squared terms, and you are subtracting them, then you have a hyperbola. All right, now this is the last of the conic sections, okay? So let's make sure we got this straight. If I have 1 squared term, it's a parabola. If I have 2 squared terms and they're subtracted, it's going to be a hyperbola. If I have 2 squared terms and they're added, it's either an ellipse or a circle, depending on what? Coefficients, the same or not. Okay? 2 squared terms subtracted. It's the only one that's going to have a subtraction. Now, as we talked on Friday, almost every, or whatever day that was we were last together, almost everything about the hyperbola is like the ellipse. There aren't very many differences. So, where's my center? Watch it. 2, -1. There is a place where we can make a mistake if we're not paying attention. The order of the letters in the equation doesn't change the fact that when you write a point, it's x comma y. Points are always x comma y. So it's 2, -1. Everybody hear that? Okay. Now, see that 4 right there? See it's under the y? What does that tell me to do? Start right here and do what? Up 2 and down 2. So up 2 and down 2. Okay? Just like with the ellipse, no difference. What does that 9 under the x tell me to do?
Right 3.
Right 3 and left 3. Now, here's where we get one of the differences. So far, this is exactly like the ellipse, right? I have not done one thing different. If this were an ellipse, I would draw a nice little oval through those points. But it's a hyperbola. So we're going to draw a box, draw a rectangle through those points. Now, once you get the box drawn, draw in the diagonals of the box. These are going to be the asymptotes of your hyperbola. Okay, everybody with me? Now we got to sketch the hyperbola, so you know what it looks like. It's either going to open up and down or it's going to open sideways. The determination of which way it opens depends on the letter that comes first in the equation, the positive variable. In this case, it's y, so the hyperbola opens in the y direction. If I turn these two things around, every point on here would be the same, but I would be drawing this hyperbola instead. So how do we know which way our hyperbola opens? Whatever letter comes first. It opens in that direction. Whichever letter's the positive one. It comes first in the equation. This axis right here that join, okay, first of all, these 2 points then, the circled points, are the vertices of the hyperbola. Those are the vertex points. Those are the vertices. These 2 points are not vertices. Does that make sense to you? They're not on that curve. Do we need these 2 points? Yeah, to graph the box, but they're not part of the hyperbola itself. There are 2 vertices. Right here they are. These are the vertex points, the vertices. The axis that joins the vertices is called the transverse axis. That word makes sense to you. Transverse joins the vertices, across the vertices. So the length of the transverse axis in this case is 4. Because to get it, I went up and down 2, right? This other axis that is not part of the hyperbola really is called the conjugate axis. And the conjugate axis in this problem is 6. When you built the box, you went up and down 2 and sideways 3. So in an ellipse, we have 2 axes. We have the major and the minor. Major is the long one, minor is the short one. In a hyperbola, you have 2 axes. One that joins the vertices, and then the other one. Everybody good? Now, if I extend my transverse axis, so it's going all the way up and down through, it's kind of like the axis of symmetry in a parabola. And the foci are going to be on that axis. Which means that they have, what? What coordinate do I know?
2.
I know x is 2. To figure out y, here's my center. I need to know how far it is from the center to the focus. Just like I do in an ellipse. I find the distance from the center to the focus. Now remember, in an ellipse, you take these 2 numbers and subtract them, right? In a hyperbola, we take these 2 numbers and we add them. So the distance from the center to the focus is going to be root 13. Now that is from the center. Don't get crazy and start somewhere else. This is from the center to the focus, always. All right, so I'm going to start at this point, and I'm going to go up root 13. So what is this y coordinate? Negative 1 plus root 13? I'm starting at the center. Always the center. And then I'm going to start there and go down, so this would be negative 1 minus root 13. Now, the fun's not over yet. Now we need to find the equations of our asymptotes. We have two asymptotes. Remember those diagonals you drew in of the box? You're going to write the equations of those lines. To write equations of lines, you need a slope and you need a point. Just like you did back in 7th grade, it's no different. We're writing the equation of a line. Give me a slope, give me a point. Alright, so here you go. Let's look at this asymptote right here. Do I know any points on that line? 2, negative 1. In fact, isn't that point going to be on both asymptotes? Alright, so let's go back to this one now. I need the slope of this line. Now think about building the box. Think about building the box. You count, to get this corner right here, you counted up, how many? Up 2 and over 3. Didn't you count up 2 and over 3?
Yeah.
So the slope is 2/3, positive 2/3 for this asymptote, up to right 3, and up to left 3 for this asymptote. So this one's negative 2/3. So now we have our slope and our point for both asymptotes, and we can write our line. So I don't know how you do that. I'm a point sloper, so I'll do it this way, but if you want to do y equals mx plus b, you certainly can. So for this one, I got y equals 2/3 x minus 7/3. And for this one, I got negative 2/3 x plus 1/3. All right, see if you match those. Anybody have a question about that? Anything there? We're going to do another one here. Real quick.
Is this gonna be in the quiz?
What?
Is this part gonna be on the quiz?
No. The quiz is circle. It'll be on the next quiz. Quiz is circle, ellipse, parabola. All right, let's do one more of these, and then we'll have to put it in standard form. Because I'm going to give you one more that's already in standard form, and then we will put it in standard form. Okie dokie, here we go. Alright, first of all, everybody recognize it's parabola? Okay, or parabola. Hyperbola? Everybody recognize it's a hyperbola? Alright, so here we go. Where's our center?
-1,
1, 2. What's this tell me?
Up 4. I mean, right
Watch it,
4.
look where it
Left
is.
4.
So this says go sideways 4. So 1, 2, 3, 4. So I'm at 3, 2. 1, 2, 3, 4. Negative 5, 2. Alright. And then this guy tells me to
Up and down.
3. So negative 1, 5. Negative 1, negative Alright, so everybody good on placing those 4 points? Just by counting up and down, sideways. Now let's make our box. So just draw a nice little rectangle. Do those points. And put in your asymptotes. Now it's decision time. You gotta figure out which hyperbola you're gonna draw, because clearly you can draw one this way, but you could also draw one this way. So we have to decide which one it is. So we look back at our equation, see who's first. So that means we're gonna draw this one this time. He's framed by those asymptotes. That means that in the little blank that says vertices, the points that you write down are -5, 2, and 3, 2. Those are the vertices of the hyperbola. How long is my transverse axis? How long is it? 8. We went back and forth 4. How long is my conjugate axis? 6. We went up and down 3. Now my foci are going to be back here. And in order to figure out what they are, I need to figure out how far from my center. Remember, we always start counting at our center. How far back and forth am I going to count? Well, in this hyperbola, from the center to the focus, oh, this is a nice one. The center to the focus is what? 5. How do I get the distance from the center to the focus in a hyperbola? Add the denominators and take the square root. So I'm going to start right here at the center, and I'm going to come back 5. Which puts me where? If I back up 5. -6, 2. And if I go forward 5, 4, 2. There are my foci. The only thing left to do is find the equations of the asymptotes. So here we go. What do I know about my asymptotes? I need a point and I need a slope. What do I know about it? What point do they have? Both of them have. -1, 2. So I'll use that point. What's their slope? Think about building the box. You count it up. How many? 3. And over how many? 4. So one slope is 3/4, and the other slope is -3/4. The slopes will always be opposite of each other, because one's going up and right, and one's going up and left, so they'll always be opposite. All right, so here we go.
Can you do it with y equals mx?
Absolutely. You can write the equation line any way you want. We should end up with the same answer. Alright, does that look okay? Do they have a question about that? Alright, well, we got a quiz tomorrow, you know what it's over. And we'll finish up the Hyperbola section tomorrow. We're gonna get a couple more sections to go. You should have done